and then the name of the shared folder, then whatever folder I wanted to mount it to. Now the option I would specify, it's a Samba file system, so SMBFS, or actually I could use SIFs with Windows as well. I'm specifying read-write. I do need to specify credentials as well, and that's going to be the username and password. And I would need to add this into the options list on the FSTAB line. And so that means, my server booted up and it read the FSTAB file, either example 1 or example 2. Not only would it mount the local partitions as I told it to on the local hard drives that are physically connected, but it would go out on the network and see what types of shares that server connected to and mount those and make those available to users as well. So that would be great if I had network storage or a network file server or something like that. Okay. So let's look at what we've covered so far, right? We've covered the device and the mount point and the file system, and now let's look at options. There are many, and this is sort of a large section here. So if I come down to options, the user ID and the group ID sets the owner and the group. Can be the user's name or their ID, just as the GID can be the group's name or the group ID. And let's see if up here I kind of threw an example. Here's an example of mounting NTFS, right? I'm choosing NTFS 3G, and I couldn't fit all this on one line, but just imagine this is on the same line. So auto, users, any user can mount it. Now I'm using the user ID 1000. And if you're not sure what that is, if you take a gander, take a look, let me go and, let me pull this over here, and let me cat etc password. And if I look at the contents of this file, this will give me users and their passwords that I've created. And I could also look at groups, cat etc group, okay, and user groups and their group IDs. And if I were going to make a user, let me do this: sudo user add, and we'll call her Samantha. And let me give her a password. And password, and password. And again, now let me cat etc and okay. And so there's Samantha, there's her ID there. And let me cat, if I were going to make a group, let me do and let's do okay. And if I were to go to etc group, and then there's the group ID. So the GID, alright, and the UID. The UID and the GID. So not hard to get, if I have a user. So I would add this if I wanted to give that particular user and that particular group permission to access that particular partition. And that's what you would call, the UMask, the user mask, okay? And the user mask would be, let me go find a UMask here. Here you go, here's a UMask up here for the VFET. Alright, so the user mask would govern the user and the group and other. Remember, just like when you chmod, there's 3 categories. So that's the user, that's the group, and that's other. Now it is the inverse. UMask is the inverse of chmod. So if I were going to give somebody full permission, I would do sudo chmod 777 and then some object, and that would give all the permission read write execute to the user, all the permission read write execute to the group, and all the permission read write execute to other. So like Windows is everyone, but UMask is the opposite. It's the inverse of that. So what I'm saying is, what would I take away? So here I would take away no permission, and no permission. So whatever permissions they had that I had chmoded via POSIX permissions, that's what they would have when that partition or that drive was mounted. All right, that's the UMask. That's part of it. So in addition to the UMask, we also have a DMask. Okay, and DMask are the directory permissions to remove. And again, that's the inverse of chmod. So on that directory, if the DMask was set to 0, 2, and 7, here I'm saying remove no permission. Here, remember, it's read and write and execute, so I'm saying remove write. And here I'm saying remove everything. That's the directory mask or dmask. Now the file mask is, again, it's the inverse, just like the umask and the dmask, but the file mask has to do with file permissions. And remember, it's saying what would you remove, not what would you add. So in this case, I'm removing the execute permission. Remember, it goes read, write, execute, and that would be 4 and 2 and 1, the way POSIX permissions work. Here I'm removing the write and the execute permission. You just add them together or concatenate, that's 3. And here I'm removing all permission. Okay, on the F mask there. And again, if we go up here, we can look at a syntax example. Let me hop on up here and just looking at a syntax example. Alright, so here's the U mask, and here's the D mask, and here's the F mask. And that, you can carefully control access to that partition, to that folder, by setting those options. Pretty much everything you can do with access control entries and a discretionary access control list and Active Directory in a Windows environment and NTFS, you can do the same thing with Unix and POSIX permissions, or in Linux. But now these last two are short and simple, but we haven't finished all the options yet. I mean, that covers the UMask, the DMask, and the FMask. Those are some of the permission options, but there are more. There's read-only or read-write, and they are self-explanatory. SWID and SKID, so the special user ID and the special group ID, whether or not I'm going to allow that. User, it'll permit any user to mount it. No user means that only root can mount it. Execute, I will permit the execution of binaries. No execute means that you will not be allowed to run programs on that directory. It's a good safety precaution for, say, if I'm going to share something online and I don't want people to be able to run executable code, which could be worms and viruses and so forth. Auto, to mount things automatically, or no auto, not to mount things automatically, to specify manually. Sync, to synchronize, or to not synchronize, to be asynchronous. If it's synchronized, then I/O processes will wait, in one after the other in proper order. And asynchronous, it's sort of a free-for-all. Although there is a performance advantage. In this case, whether a not dev or no dev, whether or not to interpret character and block special devices, or no devices do not do so. And the underscore netdev is special. It's for mounting network shares, such as NFS, Samba, SSH, FSFs. And it simply says wait until the network share, wait until the boot process is finished and the network has come up and any connected shares have been connected to, and then try to mount it. Because of course, if it tried to mount it before that happened, it wouldn't be able to find it. There would be no point. So some interesting options there, and those are all part of this, the options part in syntax. And then finally, dump and FSCK order. And this has to do with whether or not you're going to back it up and whether or not you're going to do a file system check when you boot. FSCK, if you haven't used it, sort of like the Linux version of CHK-DSK. Syntax is very similar and the way it works is very similar. So again, 0 will ignore it. Remember in the computer world, 0 is false and 1 is true. So 0 false, ignore it, don't back it up. 1 true, back it up and pay attention. For FSCK, again, 0 is false, don't bother, don't check it. 1 is true. Yes, please check it. Okay. Now, currently in Ubuntu 10.10, in Maverick Meerkat, and also in Lucid Links, these are the values of when the defaults. If I just say defaults, it will be mounted as read-write. The substitute user ID. In this case, you want to kind of prevent programs and things from executing. Device here, execute. Things will be allowed to execute, but we don't really want to allow, or we want to limit root access with the special user account. Auto in this case on the file system, and no user and asynchronous. Those are sort of the defaults there. So go ahead and save that, and we will mount them. We will come back and mount these in our next step. So, having gone over this file and configuration, having talked about what all the permissions are, this is what we'll need to tweak